Of trig, but before we get, do you know what trig is, by the way?
Yes.
Okay, good. Before we get to that point, though, we need to do a little bit of introduction stuff involving ratio and proportion. We'll also spend some time reviewing the three parts of the Pythagorean theorem. The a squared plus b squared equals c squared, the a squared plus b squared is greater than c squared, and the a squared plus b squared is less than c squared. But we'll save that for the end. Okay, first question. First question. First question. Maybe not.
What's a radio?
It's a radio.
No.
And it's broken.
I'm pretty sure it's a radio.
No.
What is a ratio?
What is a ratio? There we go. What's a ratio? It's a comparison of things, so you guys can read. Very good. Give me an example. David.
Like number of students to desks.
Good. What would be the ratio of the number of students to desks in here? That's an excellent example.
27 to like 29 to 30. Right?
Hold on. Hold on. I want to see how he processes. So first of all, how many students are in the room?
Like, I'm not sure.
Well, look around. How can you easily figure out how many students are in the room? You could count. Go ahead, count. By the way, you should all be doing the same thing. Count the number of students in the room.
26.
Someone's asking. Are we counting Jack or not?
No, it's the key.
Oh,
All right, what do you got, David?
26.
Now tell us how you got 26.
Well, there's 5 people in this row, so I added it to this 5. And then there's 6 in that row, which is 16. And there's 4 in that one, which is 20. And there's 6 in the far right, which is
Beautiful.
26.
Anybody do it a different way?
I did like multiplication by an array. And
I'm
then
sorry, you did what? I'm sorry.
I multiply like how you find arrays like in second grade. 1, 2, 3, 4, 5 times 6, and then I subtracted the people who aren't here.
Okay, so 5 times 6 is 30, and then you subtracted the empty
4,
desk.
yes.
Beautiful. Anybody else? Do it a different way. That's it? Okay, the way I did it, in case anybody cares, is I put Tegan into that desk. So that made it 5 by 5, and then max was 26. Another way of looking at it. Okay, so back to you. Ratio of students to desks is,
26 and 30.
which would be
13 to 15.
beautiful, 13 to 15. Can that be reduced further? No, so we just leave it as 13 to 15. How would you like to express that?
Like, isn't it like it's like the 13? It's like the colon.
Like that?
Yeah.
Perfect. What do you got?
Couldn't you also do it in a fraction? And you have to like label which one is which?
No, you don't have to label anything. We just leave it like that. Any other ways to express a ratio?
I'm not sure if you can, but can't you put like a 2, like TO?
Yeah, you could use the word two.
Yeah.
Good. Anything else? Okay, those will work. Which one do you think we're going to use the most? We're actually going to use that one the most, because we're going to solve some math problems involving ratios. So for instance, the question I would have is we have a ratio of 13 students to 15 desks. And David, the question I would have for you is if there's 300 and, no, is there 300? There's more than that. If there's 525 freshmen, how many desks would there be? What did I say, 520?
5.
525.
525.
Wait, 520 students or desks?
525 freshmen. How many desks would we need if we keep that ratio the same? We'll come back to this later. That's the question I'm gonna pose eventually. I chose boys to girls, but students to desks is good. Freshmen to seniors. That's about 1-to-1, I think. I think there's about the same number of freshmen as our seniors. Wingspan to height. You know what your wingspan is?
Slightly more than right.
It depends on the person, but for the most part, it's about the same. You know what your wingspan is?
I think my wingspan's like 5'7".
Come here, get up.
Okay.
Put your wingspan on the board there.
Okay. I could be wrong.
Oh wait, you gotta move over more. There you go. Do you know how tall you are?
I'm 5'6".
Measure that. Don't include this one, that's the wrong one. Measure from there to there. You want the pen to mark off?
Yeah, that'd be great. I'm gonna mark off every
What do I do? Foot?
Yeah.
Okay, 1, 2, 3,
It's 4 feet tall.
4, 5. Ooh, are you 5'7"?
No, I'm 5'6".
Oh,
I
your
just said
wingspan
you're
is bigger
5'6".
than your, okay, cool.
I made it to that.
So it depends on, some people have big gangly arms, some people have short stubby arms. Depends on, your build. What do you got going on there, Sterling? Got little raptor arms going on? Do you know what your wingspan is?
I don't know.
Do you know what your height is?
Yeah,
Are they the same?
I don't know.
Do you wanna see?
Sure.
Get up.
You good, man?
Me?
You're a little giggly.
How tall are you?
Like 6, like and a half.
Like 6?
Like.
It's what, 6 inches, 6 centimeters?
No.
You lined up there?
Yeah.
We'll measure that last little bit. You're not 6'3", are you?
I don't know.
Back to the board.
Wait, what do you mean?
Put your
Oh.
back to the board. There you go. No, I don't need your arms. Okay, step away. So this was 6'3", right?
I guess.
Leg give out there? Or you got old man knees? I'm not used to bending over.
That's like 12.
6'1".
Oh.
So your wingspan, what was yours? Your wingspan was
5'7".
bigger?
Yeah.
Yeah. His wingspan was, but your wingspan was bigger by an inch.
Yeah.
His is bigger by 2 inches?
2 inches, because I'm better.
I think it's all proportional, honestly.
I don't even have a comment for that. We did this already, so ratio can be expressed as a fraction, which we'll do most of the time. We got the colon business, we got the word too. Okay. All right, try that example first. Get a little math involved here. I'll put my new magnet up. Feel free to bust out your calculators if you like, don't be bashful. You might not need it. Guess and check. You did what? I'm sorry, divide. What are you doing? Guess and check. Okay, that's fine. What do you got? Focus? Okay, so almost everybody succeeded in drawing a rectangle, that's good. Yeah.
Is that the only thing we succeeded?
Well, almost everybody, I mean, oh, look
Is
at
that the only thing we succeeded at?
no. Here, hold that. Okay, what do we know about this rectangle?
Rectangular.
Good. Thank you, Captain Obvious.
It's a rectangle, it's closed.
What?
I got 20 to 10.
20 to 10. The measurements are 20 by 10? Okay, tell us about that.
I divided 60 by 2.
Does that check out? 20 plus 20 plus 10 plus 10 is 60. Right, so that satisfies this part of it. Good. Then what?
So to get it, I divided 60 by 2, and then I just did 30 and 10. I don't know.
Divided 60 by 2 and then
20 and
a 30 and why 20 and 10?
Because it added up to 30,
Couldn't you do 29 and 1?
I guess. Yeah, never mind.
So we could have something like this.
Yeah.
Or it could have been 15 by 15. So why 20 and 10?
I don't have an explanation for that.
Okay. Are you waving at me or did you have some? You,
Pulling up my head.
I understand. What else we got? Go.
I like made a rectangle with a side length 3 and the side, or the width 2.
Okay, hold on 1 second. So you made a rectangle with a side length 3 and another side of 2.
And then I found the perimeter of that one, which was 10.
3 plus 3 plus 2 plus 2. Okay, so the perimeter of this is 10.
And
Okay.
then since it's 6 times less than 60, I multiplied each side by 6.
Ooh. So 60 divided by 10 gives you this value of 6.
So then I multiplied each side by,
So you took that puppy times each one of those.
yeah.
Interesting. So that's 18 times 12. What's 18 times 12? 216. Anybody else get 216? Tegan, how'd you get 216?
I did something similar, kind of, where I started off with a rectangle, and then I had like the length 3x and the width 2x.
Ooh. So you introduced a variable. Let's do it up here. Yeah?
And then I added up all the sides and I set it to 60. And then
So 3x plus 2x plus 2 is 10x.
Yeah. And then I set it to 60, and then I solved for x at x equals 6. And then I did the same thing where I like plugged it back in.
Good. Two different ways to find the same scenario. Anybody else get 216? Find it in a different way though. Yeah.
I just guess and checked.
Guess and check is a possibility. The only problem with guess and check is that what if it's not a nice pretty answer, but it still gets you where you need to go. You were able to answer the question. Okay. So how did you start guessing and checking?
Well, like I just took a guess and did 15 and 10, and then I realized that wasn't enough, so then I just added
So hold on. Why 15 and 10?
just a number I thought could be the answer.
Okay. So
Educated guess.
basing it off of what Camille started with by taking the 60 and dividing it by 2, so that you only have to face, or not face, but look at those two sides.
Mhm.
Okay. So you did what, 15 and 10?
Yeah, and then I
Okay.
realized that only added to 50, so then I added 3 and 2. So that, and I got 18 and 12 as the two sides.
So you got it in the first shot. Well, second shot.
Yeah.
Okay. Good. Any other ideas? Go.
So I divide 60 in half because it's only the two sides.
Mhm.
And then I looked at the ratio, and I was thinking, since both of them add up, I kind of like made since they add up to 60, I added 2 and 3 as 5, and I divided 30 by 5, which is 6.
Okay, hold on, I gotta write this down. So you took 60 and divided it by 2, which gave us that 30, same idea that Camille started with.
Yeah.
So you're just looking at these two sides, this one and this one.
Yeah.
Okay?
And so since the two sides have to add up to 60, I added 3 and 2 from the ratio to 5, and I divided 30 by 5.
So then took 30 and divided by 5.
Yeah, which equals 6. And I multiplied both sides of the ratio by 6, which is 18.
So you kind of combined this approach, Caitlin's approach, and who's the green? Tegan? All right, so you combined the two
Yeah.
to get the same. So you found that value of 6. Okay, good. All of those are viable alternatives. Which is the best one? It's entirely up to you. But notice we've got a rectangle. I would say in general, this method will probably be most consistent for you, because I could change the problem and say, well, what if they're not sides of a rectangle? What if they're sides of a triangle? What if they're the angles of a triangle? You know, the angles of a triangle are a ratio, blah, 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 blah. This idea of using a variable will work always for you. This method, these other methods, even though they work well, they don't always work as well for different problems. And you'll see I've got a couple other examples for you to work through. This thing here that we found, this value of 6, we found here, we found here, we found here, is called the ratio constant, or the ratio proportion, or proportionality constant, I'm sorry, I used the wrong term. It's that number that you're going to multiply the sides by. Notice it's not telling you that the sides are 3 and 2, because we started with that somewhere. Yeah, Caitlin started with that and realized that's not 60. But it's the value that when you take those sides and reduce them, so we actually found out that it was 18 and 12. When you reduce that ratio, you get down to this factor of 3 and 2. Okay, so by introducing a variable there, it makes the problem much more solvable. Question?
Oh, what did you say that the answer was called?
Oh, the number?
Yeah.
That's proportionality constant. Okay. Now, using any one of those techniques, solve that problem. But again, you know, the question I'm going to ask you is not only what's the answer, but how did you solve it? Okay, what do you got and how'd you find it? Oh,
40, 60, and 80.
okay, so you got. Hold on, my pen's freaking out here. Or I'm freaking out, one or the other. 1 second. Come on. Okay, what'd you say?
40, 60, and 80.
How'd you do that?
I drew a triangle and then I thought like if triangle is 60, 60, and 60 to make 180, then you would subtract 20 from the first one. So it would be 40, then you could add 20 to the next one and then 20 to the next one.
Okay, so are these, if this is true, then these two should be in a ratio of 2 to 3, because that's smallest to medium. These two should be in a ratio of 3 to 5,
Oh yeah, I did that.
and these two should be in a ratio of 2 to 5.
Yeah, I did that.
Okay, so 40 over 60 is actually, well, that's 2 to 3.
I
Right.
think the next one is
The 60 to 80,
yeah.
oops. That's a 3 to 4.
Yeah.
Okay. Charles,
I did it a bit different. I did it a bit algebraically.
what are
so-
your answers?
What?
Answers.
I got 90, 36, and 54.
How?
So what I did is I took just to visualize it, I did like a picture of a triangle, and each of the sides I put is 5x, 2x, and 3x.
Each of the sides?
Angles, sorry.
Okay.
And then I just add, and then in an equation I said 5x plus 2x plus 3x equals 180.
Uh-huh.
And then I just solve for x, which I eventually get to be 18. Then I had to plug them back in. So 5x is 90, 2x is 36, and 3x is 54.
Okay. Anybody do it differently? Okay. Beautiful. Remember, the angles of a triangle add up to 180, the sides do not. So if you're given sides in that scenario, you're going to have a completely different approach to that. Okay, what's a proportion? Or what's it mean to be proportional? And or can you give me an example of things that are proportional? This one you're on your own, I'm not giving it to you. So I've even heard some people use the term already. What does it mean? Go ahead.
The ratio, pretty much the ratio of one thing to another thing, like, and then like, if it's proportionate, it means like something else like shares the ratio of that one thing and the other thing. So like, if I had like a rectangle, like that had like one side, with a length of 1, and another side with a length of 1.5, then the proportion would be 1 to 1.5.
No, that's a ratio.
Well, it's used to keep things.
Well, what you just described was a ratio. How do we extend it into a proportion,
Well, like the equivalence to another one.
for instance?
So like 1 over 1.5 is 2, 3.
Is it?
I don't know.
Is it?
Yeah.
Yeah, okay. So again, gesundheit. So what's a proportion?
It's the relation of one ratio to another.
So ratio is a comparison of things, normally numbers. But now if we decide to compare those ratios, then we get a proportion. Not all proportions are true. Some of them can be false. Okay, so for instance, 1/2 is not equal to 3/4, but you can still compare them. We want true proportions, and when they're true, they're called proportional. So some examples. 7 pencils cost 25 cents. How much do 400,000 pencils cost? We'll solve these later, by the way. 10 boys to 11 girls. How many boys would there be in school if there are 850 girls? That's a moose. I don't know why.
The moose can be very deadly.
There's a standard proportion. A, B, C, and D are normally the letters used. I don't know why, it's just the tradition. And there's a reason why the B and the C are red and the A and the D are blue. Go. Oh, go.
Is it because the one, like, diagonal from it, the one the same color, in that case, you multiply it?
Ooh, we'll get to that in a second. Cool your jets for a second, Chica. The blue ones are called the extremes. The red ones are called the means. And based on what Mary just said, what can we do with those means and extremes? Mary,
So we can multiply it.
multiply. What's that called? The means extremes product property, also known as cross multiplying, correct. Okay, so we talked about that already. Proportional means it's true. Just because you have a proportion doesn't make it true. How do we check to see if it's true? Then we get into what Mary's talking about, which is the cross product. Okay, which you knew that already. Cross multiply. Means times extremes. Sorry, the product of the means equals the product of the extremes. I think, is it safe to assume you can all cross multiply? Yes, okay. If a proportion is proportional, then when you multiply out that proportion, in other words, you cross multiply, you should get an equivalent value. So if we look at something like what Charles said, 1 to 1.5 is equal to 2 to 3. How do we know that's true? Cross multiply. 1 times 3 is equal to 2 times 1.5. And sure enough, 3 equals 3. Boom, proportional. So we can use cross multiplying to check answers. We can also use it to solve problems, which is what we're going to do. We're going to figure out how much 400,000 pencils cost. We're going to figure out all those other things that we wanted to solve earlier. Okay, so wait, let's take a break for a second. Let me ask you another question. We've got A over B equals C over D. There's my starting proportion. I would like you to try and rewrite that proportion. Let's try 2 different ways that still gives me a true statement. There are ways that you can rewrite it in a different proportion, get a false statement, but I would like you to rewrite this at least 2 different ways so it's still a true statement. Go ahead. Still needs to be a proportion, just put the letters in different locations. Skateboarding bear. That is a bear, right? Yeah. It doesn't work left to right though, it only works up and down. Oh.
Stop.
Goes from starting to looking panic me one.
B over A is equal to B over C.
Badger over aardvark is equal to donkey over cat. Is she right? How do we know? How do you know it's the same thing? Max?
They're just flipped,
Well, how do you know it's the same thing?
because it's still B times C and A.
There you go. Over here, we have A times D is equal to B times C. If we come over here, we have B times C is equal to A times D. Same thing? Yeah. How'd you get that?
I just flipped them because I knew.
Flipped them. Good. What's that called when you just flip them? Reciprocal. Good. Took the reciprocal of both. Somebody got another one? Max?
D over C equals B over A.
Donkey over cat is equal to badger over aardvark. Yeah. Is he right?
No, we just
A times D is equal to B times C. How'd you get that one?
I took diagonal, so I just switched the placement of them. Like I switched D with A and B with C.
Yes, and actually ended up doing something even easier. That's Caitlin's, that's flipped over and then using the, what's that property? Commutative property of equality. Put one on one side, one on the other. Okay, good. What else? Max?
D over B is equal to C over A.
Donkey over badger is equal to cat over aardvark. Well, there's my A times D equals B times C. A times D equals B times C. How'd you get that?
I just, I swapped the place of A and D. I switched them.
Just switched A and D. Okay? Which means that theoretically we should be able to just switch B and C, correct?
Yeah.
So couldn't we get another one that says B and C? So A over C is equal to B over D. Another one? Okay. Any others? Max?
C over D equals A over B.
C over D equals A over B. Oh, switch the location again, using commutative property again. Put them on the other sides of the equal sign. Okay? Anything else? All right, here's the hard one. What doesn't work? In other words, give me some wrong answers. Max?
Switching A and C.
Switching A and C, so we'd have C over B is equal to A over D. Whoops, that's supposed to be a D. Donkey. Because now when we did this one, we had A times D equals B times C. This one, however, we have C and D multiplied together. Good. Okay, so there are combinations that don't work. We want to make sure that we keep them in the same proportion. There are a lot of different ways to set them up, and in fact, you'll see when we get to the example that we're going to do in a second. Cross multiplying, reciprocal property, we did that one already. Flip it over, yep, okay, great. Yep, All right, there we go. Solving this problem. How much do 400,000 pencils cost? Because we looked at least 4 different ways that we can set up a proportion, there's at least 4 different ways that you can set up this problem. The key is getting the answer right. When you're done with the problem, you want to ask yourself, now, obviously this is a ridiculous question about who wants 400,000 pencils, but ask yourself a question when you're done, does that answer seem reasonable? Okay. For instance, if you get 5 cents, you probably did something wrong. If you get $300 billion, you probably did something wrong. Set up a proportion, solve. And feel free to do it as dollars or cents, it doesn't matter. Nicole, let's start with you. How'd you set it up?
I put 7 over 0.25
Whoops. Uh-huh.
equal to 400,000 over X.
Who set it up the same way? Okay, beautiful. Cross multiply, solve, do all the math magic, and you find out that 400,000 pencils costs
14,285, and then it got like 0.7142.
Okay, 71 cents is important. $14,285.71. Is that reasonable?
Yeah.
Yeah, if you're buying 400,000 pencils, that would work. Who set it up differently? Max?
I kind of just did like the division. Kind of set up proportion or ratio.
Be specific. You divided what by what to get the there, and then to do the HUD, and then and the answer.
0.25 divided by 7 and then times 400,000.
Okay, so wait, 0.25 divided by 7 gives us what? Not necessarily the answer, but what does that represent?
What each pencil costs.
Good. So he did 0.25 divided by 7, that's dollars per pencil. And then took that answer and did what with it?
Multiplied it by 0.25.
Beautiful. In essence, you just solved a proportion, you just didn't set up the proportion ahead of time. Mary, what do you got?
Oh, I just have a question. Isn't something where you get it down to like 1 to whatever number, is that a unit rate?
Yeah, our unit here would be, well, our unit actually is a comparison. It's dollars per pencil is what Max did, and then when he's done, because he's multiplying, we end up with a final answer of dollars, because that's money. Anybody set the proportion up differently? You all did pencils to dollars equal, or, yeah, pencils to dollars equals pencils to dollars.
I did dollars.
Dollars to pencils, you flipped it over. Nancy, what did you do? Well, it's right there in front of you.
It didn't work.
Okay, what did you try? Because I saw this. Right, so you did pencils to pencils equals. What should this side be?
20 to 20.
Anybody else? Bella.
400,000. Then 0.25 is on the bottom.
Good. Cross multiply and solve. All right, I'll post the homework from chapter 5. Have a good day, everybody. Welcome back. 3 weeks till finals. Woohoo! We didn't finish. That's okay. You're welcome. See you later.